Welcome to today's webinar, Empower and Engage Your Students in Math and Science through UDL, brought to you by Simple K-12. My name is Lori and I am here with John McGowan, and we are so excited to have all of you here with us today. Now, this webinar has been brought to you free today thanks to our sponsor, Texthelp, the makers of EquatIO. EquatIO makes math and STEM subjects digital, enabling teachers and students to create equations, formulas, graphs, and more directly on their computer or on their Chromebook. Now, just a little bit about our presenter. John McGowan is a certified Google education trainer and the creator of GMath, which had over 13 million worldwide users before it retired in January 2018. And after teaching math for over 15 years, he joined Texthelp with the goal of making digital math easy and accessible to all. And EquatIO is the first step in that journey.
Hi, thanks so much for sharing your Saturday with me. I'm here to talk about empowering and engaging your students in math and science, and essentially STEAM through UDL. So my name is John McGowan. I am a math teacher at heart, but I'm no longer in the classroom. I am the product manager at Texthelp for EquatIO. How did I get here? I was a classroom teacher, and I wanted my students to collaborate and use a bunch of new technology. And I created a Google add-on called GMath. I got a lot of users, millions and millions, and I ended up bringing it to Texthelp, and we turned it into EquatIO. So I'm so excited. My mission and passion in life is to make digital math and science creation delightful, intuitive, and fun. Those three words are generally never used with equation editors or math notation or STEM content. So I'm hopefully to bring that barrier down. So let's talk a little bit about communication. So for me as a teacher, I think about, I want to communicate with my students and I want them to communicate their thought process. And that's really the heart of everything I do. There's a bad joke that I would always use and say, if you solved a math problem in the woods and didn't tell anybody about it, did you really solve it? And so I think that is the heart of what we're trying to have students be able to do, that we want them to have the fluency to be able to explain their thought process. And then after they can solve it in one way, I would ideally like them to be able to solve it in multiple ways and explain their thought process in all of those. And then what are the differences and what is the thought behind some of those changes in communication methods that they used. And so I think that's the big thing at the heart of any content that we have, especially in STEM content and in STEAM. I love the A in there. I was at my heart. I love art and visual aspects and colors and lots of major things. So I'm really excited to bring that component in. I think visualization for me is the reason that I love math. I love the elegance, but I also love the visual component connected there. And that's the method that I prefer to learn in and the method that I default to teaching in. And so I think that is also connected to one of the hardest parts about STEM today. And pencil and paper are the best method, or best for math. That's what I always hear. I've done so many sessions around the world with math teachers about how are you going to utilize technology in the classroom. And a lot of times I get a pushback and say, well, paper and pencil or pen and paper are the best ways to do math. And I would agree if it's the best ways for some people. There are some people who require some accessibility where they just cannot use pencil and paper. So we're almost excluding them from the math experience. And that's not what I want. I want to empower all students to be able to fully communicate their thought process, no matter what method that they prefer and want to use. And so that's why I think also some of the time, paper and pencil is not best. And so really that's the heart of what Universal Design for Learning is. So Universal Design for Learning, or UDL, just provides a framework for students to have options. It's funny, I was a teacher for 15 years, and probably the last 3 or 4, I really started to think about accessibility and providing more options. I think it's twofold. One, I became a better and more mature teacher, so I was able to move away from the teaching and the methods that I learned best. I was able to see other perspectives and provide more opportunities for students to have other ways to see things. I also was exposed more to software and accessible technology, which at the heart, really, I think after I learned more about UDL, I thought, wow, that's just good teaching, be able to provide another way for students to think about a problem. But really, this framework is really great. So I'm going to distill it down to, I think UDL is just really providing choice. And if there's anybody on here who's a UDL expert, awesome. I'd love to communicate with you about it. Hopefully, I'm not misrepresenting to kind of distill it down to just choice. But that's really the focus, and I'm going to bring it in here now, is about choice. Because I think that students can choose the method they prefer to consume and create their STEM content, and that choice is going to increase engagement. Because really, I look back at my first probably 10 years of teaching, and I would say I would only validate communication in one way. I would tell a student, I'm going to print it on a piece of paper or write it down on a piece of paper, hand it to them. They would write down their thought process, hand it back to me. I would grade it, put that grade in the grade book. And that was really the only way I was validating the communication. We would have awesome verbal discussions, and I knew that the student would understand that, but I would only validate them by putting the grade in the grade book if they could write it down and hand it to me. Now, that, as I've come to know, through my experience, is why most people hate math. I sit on many planes, and the person sitting next to me, they talk about what we do. And every time I say I was a math teacher, I get one of two visceral responses. They tell me how much they love math, and they tell me about the whole plane ride about what they love about math and what they do and how amazing it is. And that happens about 5% of the time. And then the other 95% of the time, the people tell me how much they hate math. And usually it boils down to some teacher that they had that didn't validate their communication method. And usually they phrase that in the fact of, oh, I solved the problem correctly, but the teacher didn't like the way I did it, or I didn't do it the same way the teacher did, and they marked it wrong, or they marked it incorrect. And so I think that is something that we just really need to help shift and change, in that we can validate multiple methods of communication. And really, if you change and give them that option to how they choose to communicate, that's really going to get them engaged. And once students get engaged, then that provides the space for learning to occur. Because really, as a teacher, that's what I want to do. I want my students to learn. Really, and I'll steal a quote from my friend Alice Keeler, like, honestly, I teach students. I don't teach math. I want to teach math to students, but if I cannot create an engagement with that student, they're really not going to be willing to learn and not have that connection that provides that space for the learning. And so I need that engagement for learning to occur. And that's where I think all teachers are magicians. We all have our own flavor, our own flair that we bring to it, our own perspectives. And once the students are engaged, then they're primed to learn. And that's when the teacher can provide their magic. I think also, like in today's buzzwords of tech, in how like the AI and machine learning, artificial intelligence, like where does that, computers are not going to learn through our artificial intelligence how to teach students effectively. There's such a variety of things. I think there's magic involved in there, that the human component to be able to shift on the fly and provide an alternative explanation. Granted, we can use technology to I do like a first cut and do repetitive rote assignments, but I think that's where we should leverage technology to provide that first cut, and then take away those like really time consuming components and let teachers really use their magic. So I always say that using technology amplifies me as a teacher by almost automating those mundane assignments and bringing technology in to leverage me and make me more effective. So to kind of amplify what I can do. And so that's why I feel like UDL provides choice for students. Once they get to choose how they want to create and consume their math, then they're going to be more engaged. And then once students are more engaged, they're ready to learn. And that is the whole thought process that I think, and how we need to reshift and reimagine how we assess and also teach in STEAM. So why UDL and STEAM? How can we do that? I think we need to rethink traditional paper-based assignments. If I'm just providing some content on a piece of paper to a student, I'm limiting their ability to respond. They can really respond in one way. They can write it down and give it back to me, but I'm limiting their creativity. I'm not providing them with ample tools where they can choose which one works best, which again is like, that's a math content skill and a science content skill. Like, choose which technology or which tool or which process that you're going to use. That choice is really one of the things that we're looking for them to do. So why not give them those opportunities to choose the appropriate tool to solve? And they have preferences, so why not factor those preferences in and let them choose the way that they want to? Now, you might say like, okay, well, that is going to be really difficult for me as the teacher, because then I'm going to have to like grade multiple things. And one of the ways that this really opened my eyes up was when I first used Google Slides. I think my first case in using technology was like Microsoft Word and using a computer, and it has a really difficult palette-based equation editor. And we want to move away from that. It should be nice and intuitive and also provide choice. So when I first gave an assignment on Google Slides, which Google Docs and Microsoft Word are made to create prose, and math and science is generally not fit in the box of writing prose. We don't care about paragraphs. We don't really care about indentation and font size and all those different constructs that documents have. Now you'll see me later in a minute. I'm going to demo in a Google Doc, but I think there's a reason for that. And so it's choosing the best tool. But I think Google Slides is the medium that provides students the most choice. Once I gave an assignment on Google Slides, I was amazed that I had students who would drop in and they would make a YouTube video with their camera on their Chromebook or their phone and explain something and then edited that video. I had one student who probably spent about 30 minutes in the whole first semester working on content. It was a really battle. He was not engaged. It was just a difficult uphill battle. And then once I found out, I gave an assignment on Google Slides and he probably spent 6 hours solving one problem. I don't think he got it right either, but he spent so much time solving it with creating videos and with animations and all these different things, which let his art skills and his creativity with video management in there. And so I got a bunch of YouTube videos and I was like, wow, that really unlocked the way that he wanted to communicate with me. He didn't like my method. And so that opening where I was like, okay, in this medium, you will communicate with me. Great. Now we can steer that communication towards the mathematical concepts that I'm looking for. And I think that is the opportunity that we can seize with these students by giving them this choice or this smorgasbord of opportunities that they can have for doing different, using different tools to work in their STEM content. So I think Google Slides is a great way to give them choice. And you'll be amazed by the first time you open that almost Pandora's box, you'll be amazed at what comes back with you. And then for me, that shifted the entire way that I taught my class, the entire way I delivered it. And really, as long as I was framing it in that I wanted to increase student engagement and then increase their learning outcomes, as long as I'm doing everything from the lens that what's best for students. And honestly, I love technology. I love using really cool tech pieces. So sometimes I have to ramp back and pull back on myself and not use a tool just because it's cool, because it might not really add to the learning environment or learning outcome for the student. I'm really super lucky. My wife is also a high school maths teacher, and she is on the exact opposite for me. So she'll only use technology if it enhances the classroom. I'll use it if it's really cool. So she always balances me out and say, is this what's really going to be best for that student learning experience? So I have that question in the back of my mind all the time. Is this going to be what's best for that student learning experience? Is this going to amplify that student's experience? Is this going to empower them to communicate how they choose to communicate? And so that's really what EquatIO is all about. And so how do we do this in STEAM? What about digital notation and structure? Well, that's why we built EquatIO. So EquatIO is one of the tools I think that you could use in UDL. There's a lot of other amazing tools. I'll reference Desmos a lot. The Google Science Journal is really cool for utilizing technology and tools, and Google Classroom is great. I really love that focus of that online collaboration. That's really what I wanted to get into, is mirror that peer collaboration that students could do in the English language classroom and really get that team building and that team solution process, which is kind of what they're going to need in the workforce. And so EquatIO was built as an easy to use math and STEM editor. You shouldn't need to know any specific code. It should be intuitive. You should be able to let it flow to what your communication is. So we built it on these UDL principles to increase accessibility and then also that engagement to have a personalized learning experience. So I also think about all of those tools that we provide in EquatIO is kind of like giving students an option. And then once they make it digital, then for me on the other side of that, I can choose to consume it however I want, because I want to have, as a teacher, a digital workflow so I can amplify myself. So that's kind of the lowest common denominators. I want it to be digital. I don't care how they do it. My goal is for EquatIO to be a platform agnostic, device agnostic, and almost like method agnostic. However you choose to create your math or science content, great. We should make it digital and then make it accessible. And then once it's accessible, it's also editable. And that accessibility is a big component, because we can't just almost intentionally leave out access to students by not providing that accessibility. We need to provide accessibility so all students have the ability to learn math, science, STEAM, and just really empower them. We shouldn't be limiting their options for life and for their school experience. And by just using paper and pencil, we're honestly doing that. We're excluding a minority of the population, but I say we exclude a majority because honestly, I think a majority of people in the world hate math. And so my goal is to make them not hate math. So literally at the beginning of every year, my goal is when a student walks in the classroom, by the end of that year, I want them to hate math less than they do on the day they walk in. So if they love it, that's awesome. I want to amplify that love. If they hate it, I want them to hate it less. Ideally, they would love it as much as I do, but I know I'm somewhat of a realist as well. So what else can EquatIO do? Well, it's a Google Chrome extension, and it works in the entire G Suite. I'll demo a few different things here, and we have a bunch of UDL input methods. And we also have Desmos graphing capabilities as well. But not only that, we have an installable app that works in Windows and Mac. If you want to work in your Microsoft Word, that's great. UDL kind of says provide choice. So if you want to choose to use Word documents, that's great. If you want to use a Mac or a PC, awesome. My daily driver, the one I'm presenting on here, is a Chromebook. So I love using Chromebook. I use a touchscreen Chromebook. I went from a MacBook Pro to a touchscreen Chromebook and really can't go back to anything else. And then we also created the EquatIO Math Space. I'm super excited about EquatIO Math Space. It's literally like the digital document type that I needed as a teacher. And we're constantly evolving. And you'll see next week for Pi Day, we have a really awesome update that's coming to make it easier for younger students to create with a ton of virtual manipulatives that are really great. And so, again, I always talk about the communication and the heart of it. There's a big barrier to representing your STEM notation online. So here, this animated GIF is that it talks about math here, but you can replace math with STEAM on there because we have the same pain points, no matter whether it's math or science or the technology, the engineering, or the arts. All of that is really difficult to create online, mainly because there's not a keyboard key for a lot of the things we want to do. And there's a difficult structuring part, the vertical and horizontal structure to create a lot of these things. But really, we want to get to the heart of this. We want to get to the heart of as a teacher, I want to know, do you understand the underlying concept? So we shouldn't let these two things on the left here, the notation and the terminology, be a barrier. So for example, like right now, I'm on a Google Slides presentation, and there's a really cool thing here for the closed captions. I could turn this on and it will live capture what I'm talking about. And so that's really great. If I'm in a classroom, in a physical room with someone, I can literally put this accessibility on and it'll get my dictation here and record that for them. So if they need that verbal transition to being able to visible notation, maybe they're deaf or hard of hearing, or maybe they just can't see or can't hear if it's a big classroom. So it's a really great way to add that other method. So there are some people who require this accessibility, like maybe you're deaf, but there's also some people who really augments. I'm a really audio learner. So for me to hear something and couple that with being able to see it, it is really beneficial. So to be able to read something as a visual learner, that's a great component as well. And so that I think that we want to take all these accessibility tools, and they're required for some, but I always say they're awesome for all. So let's just go ahead and jump into a demo here. Like, how can I go ahead and do this? I'm going to use the G Suite here. I'm in a Google Doc, and I'm going to do some basic things to show these different UDL input tools. So one of the main components is, so EquatIO for Google is a Chrome extension. Once I click on the button, I open it up, I get my toolbar on the bottom with my different input tools. So I have an equation editor, a LaTeX editor. I hope nobody ever has to dive into LaTeX. It's a typesetting language that if I was a college professor and I'm going to publish in a peer-reviewed journal, I need to submit a tech file, LaTeX file, and it's essentially a typesetting language. It's amazing. It's super powerful, but it's like really, really difficult to learn. There's a huge learning curve on there. And I don't think that a third grader who's trying to add some fractions together needs to be able to represent their thoughts in LaTeX. We have a graph editor. We incorporate a full Desmos graphing experience, handwriting recognition, speech input, EquatIO Mobile, which allows you to use your phone or your iPad, your iPhone, your Android phone, or your Chromebook. It's just a URL. So I can go to a URL and use my device capabilities with my camera or the touch screen to be able to represent things. The EquatIO Math Space, I can directly insert from the toolbar. Again, I'll show Math Space, but it's essentially a digital whiteboard with math manipulatives built to do math with the EquatIO input methods. And the screenshot reader, which is really great. If I can incorporate and find any handwritten or printed math on my screen, I can take a screenshot of it and I can make it accessible, but I also make it editable by being able to copy the underlying math bits. So again, the big umbrella here is if you're doing math somewhere, no matter how you choose to do it, we want to make it digital with EquatIO, and then it makes it accessible and also editable. So here, as a teacher, my typical workflow used to be, here's a problem, give it to the students to solve. So if I use this digital method, I can share this Google Doc. I can layer on top of all those amazing capabilities for my Google, where they have the collaboration and all those. So I'm built on top of Google. So that is really great. And here, what I can do is I can utilize this accessibility. So this toolbar up here on the top is Read and Write, which is Texthelp's flagship product. I think there's something like 19 million users here. But what you can do is has this accessibility bit where I can hit play and it can read everything to me. So one of the things that we can do is if I make my math with EquatIO, make my STEM content with EquatIO, it will also read that aloud. So it creates that accessibility, which accessibility is required for some people, and I think it's just awesome for all. So if I hit play,
simplify 1/2 plus 1/3.
I can hear that read as 1/2 plus 1/3. So I think from a learning standpoint, that 1/2 plus 1/3, for me to see that, there's a notational component, but there's also a terminology here. So seeing the fraction of 1/2, I want my students to understand that that's 1/2, or that's the fraction of 1/2. So be able to write that or create that with a normal equation editor is quite difficult. So they'd have to click insert and then equation. And this is a typical palette-based editor where they have to find the button of the math that they want to build. And then on top of that, there's a cognitive load here where they have to be able to take this complex aspect and say, oh, A over B, yes, I want to make that math structure. And then I'm going to replace A with a number and B with a number, and I'll be able to make my fraction. Like that is just a level of cognitive complexity that will lose a majority of students. So I, as a math teacher, know how to work this because I've gotten used to it. It's kind of like what I expected it needed to be. And now that if we rethink that experience, we can just say like, no, we as math teachers and mathematicians and scientists, we deserve better. And so that's what I think EquatIO should be, is what we deserve is better. So I can utilize my toolbar here to just either click on this if it was created with EquatIO, or I can use a screenshot. So I can just take my screenshot reader and it will screenshot that and make it editable. But here as a teacher, I could share this through Google Classroom. I can share that doc however, and then my student can then just click edit math, and then it brings it up and writes their problem down. So that for me, I would say when my students make a mistake, so many times they transcribe the problem down incorrectly. They wrote it down incorrectly from the textbook or the board or whatever. So here we're kind of moving and shifting one of those things, that a place where a student can make an error, we get to shift that over by just transcribing it in there for them. And then now we can leverage technology. I can use copy and paste. I can use a lot of the different things that we built into EquatIO. So one of the things we built into EquatIO is a prediction thing. So here, if I want to make an equal sign, I can literally start typing EQ and it gives me equals. So that says like, oh yeah, I can see my notation and my notation and terminology side by side. So if I want to do equals, I can just click on this or hit enter and it makes my equal sign. So that's really great. I can utilize, I don't need to know what the notation looks like. I can just use the terminology. And that's, again, really powerful for students who are learning that. I think about learning new math notation, it's just like learning new vocabulary in an English language class, where learning new vocabulary, you need to learn what the word is, how to spell it, what the definition is, and how to use it in a sentence type of thing. So there's like a couple different layers that you need to learn to communicate. And here in math, we add another layer of not only need you to do all of that, you need to be able to recognize what that notation is to go along with the terminology. How do you use it? So there's an extra bit of like, you need to represent it in two different ways. So we shouldn't have to choose to do those as a prerequisite to be able to understand your thought process. So we built in here with EquatIO as of, I think in July of last 2018, we made it so you could do multiple lines. So I can now hit shift enter and I can just come down here to a new line and I can start working. If I want to make 1/2, I can start typing 1/2 and make that. That's super awesome. But even better, if I hit shift control enter, it'll copy down my line from one to the next. So again, that's another step. So many students make a mistake transcribing. They make transcribing errors from one step to the next, where from their handwriting, maybe that 3 turns into an 8, and then they use 1/8 as they're moving through here. So I think we can eliminate some of those errors that don't really address their understanding of the thought process. I think of them as almost administrative errors. They're making transcription errors or copying down things. We're also at the same time cutting down for those students who have maybe limited mobility in their hands, so they can't do handwriting very well. So we can use technology to provide those other methods where they can choose to do that. So here, if I was going to solve this problem, I can then start typing times. I can do a dot and say I'm going to multiply times 3 there. And if I want, I can literally just copy and then paste that there. And then I can even do it here as well to say that's the same process, and I'm going to change that 3 to a 2. And I can do that same process and change that 3 to a 2. So I can make that process much more quick, where that is an extra step that my students generally won't give me because it's added work if they're writing things down on a piece of paper. And now I love how I can reinforce my math concept here of 1 times 3, that's equal to 3. I always talk about equality is interchangeability, so they can just replace that with the 3. So they don't have to transcribe and replace, they can just physically replace. And that will reinforce that process of equality. And so they know that 2 times 3 is 6. And so they can just go ahead and then copy that down. Then they might say like, oh, I'm going to get them all on the common denominator. And I can use technology to kind of just leverage that. And I do that 3 plus 2 and get a 5. So why do I think that's super powerful? I get so many more steps by utilizing that technology. So I can actually figure out what is the process there, what mistake are my students making, and I can help diagnose that, because most of my effort in grading and assessing goes to where did my student make the mistake and how can I help them rectify that mistake or understand where that mistake is and correct it. So if they give me more steps to do, then I can use that more effectively. So I think that's a really great way that I can do that. So that's with the equation editor, where we have a bunch of prediction items. We have multiple lines as well. Some of those prediction items, if I start typing in here like QU, I get the quadratic formula, and I can just get a structural component that makes it represented more easily. There's a ton. If I type in IDEA, I get the ideal gas law. You can see I have matrices in there. So I also can talk about, my friend Efren always talks about a variety of things that I have. I have about 1,000. He's a chemistry teacher, so there's like over 1,000 chemical compounds. So again, notational components. If I want to talk about reacts with, I can literally just make it. Those things might be difficult components to make. Again, I don't know what this chemical equation is. Efren will probably laugh at me that those things don't yield, but I just wanted to highlight that I can do, let's see, I know that's not correct, but just to show that I can do a variety of processes here. And that notational component is really difficult for me to represent. But we can do that with prediction. So I love that aspect there. We even have, like, if I want to talk about nuclear notation, I can put in there and put some ionic aspects and the molar weight and things. Just we have that built in with the prediction, the structure needed to be able to create that for our users to be able to do that. So I love that we can do that. Even if I wanted in here to put like positive, I could to make it positive. So that prediction component makes it much easier to think about your thought process, but also not to have to pre-plan it. Again, which I'm always thinking about the cognitive load that students need to do to make digital math. We should make it easy and intuitive. So I can do that all with the equation editor. But let's go back to this problem that we had here where I want to simplify that 1/2 plus 1/3. Again, I can do that with speech input if I want. So if I have a multiple line environment, I hit Shift Enter to create that first. Now I can just use my speech input and I can say 1/2 plus 1/3 equals next step. 3/6 plus 2/6 equals next step, 5/6. And so you can see here, it didn't get my 3/6. Maybe I didn't put enough emphasis on the TH, but here I can go back now and I can edit this and I can put 3/6, or I can make a fraction, or I can also utilize here, I'm on a touch device. So if I come down here and click on my handwriting recognition, I can put my cursor here and I can say, oh, I want to just make this 3/6. And it does that and puts it in there for me. So I can do a multimodal approach where I can start with speech input and then go to prediction or whatever I want to do, and I can create that. So however that user chooses to create their math, whatever your student wants to create it, no matter what method, it gets it digitized, and then I can work on that. And the same thing, if I want to do it on a piece of paper, I could have them do the same thing that they would do on a piece of paper on their touch screen. So I can do 1/2 plus 1/3 equals, and I can even do that like 1/2 times 3/3 plus 1/2 times 2/2 equals, and then I can see here that it thought it was a 13. So I can just say, no, that wasn't a 13. That was like times 3. And so I can go ahead and scratch that out. And it should work, but it didn't really like that. I can go ahead and fix that actually afterwards. And so I get this as being 3/6 plus 2/6 equals, there we go. It must be too far down that last line, but I can jump over here if I want, and I can start saying like, oh, I want to do that 3/6. So I can correct something, and I was thinking I was doing that. I thought that was a 1/3. So you can see that handwriting recognition. As you can see, my handwriting is not very good at all. And so I think that is a good way that, for me, how the speech and the type setting is much nicer. I'll just go ahead and delete that again and say like, if I start typing 5/6 even as well. So that's something where I can use a fully from a keyboard component. So maybe I'm using a switch compatible device or something where I only want to use the keyboard shortcuts. We can do that. So however you want to make your math, we can make that possible by putting it into there. So also all of those are accessible. So here, if I would have that be played aloud, it'll read that accessibility for me. So it's a nice
full stop. Line 1, 1/2 plus 1/3 equals. Line 2, 1/2 times 3/3 plus 1/3 times 2/2 equals. Line 3, 5/6.
So that's a really great as well for my students. So I can create those solutions and pass it on to them, and they can hear that be read aloud to help cement what that notational component is along with the terminology. So on top of that, like that's one method there. So I used I used my equation editor. I've shown the handwriting recognition, the speech input, all of those different UDL approaches. But I'm going to show now here the EquatIO mobile. So all I have to do is go to a URL, m.equate.io, and it knows where EquatIO is open. And I can kind of be my extension of my cursor. So if I click on here, this is just a URL. You can imagine this being on my phone. I have a touchscreen Chromebook, but I know most students have a touchscreen phone, whether it's an Android phone or an iPhone or an iPad. And you can then utilize the touch devices. You can use the camera, or I'm going to use the handwriting here. So I can go ahead and do that same process. And maybe I even want to talk about like, I'm going to do 1/2 plus 1/3. So maybe I have that same box and I want to put that in there. And so I might even show that that's going to be the same as like 1, 2, 3, 4, 5. And I'm going to take that 1/3 and that 1/2. And so I can then show that I have these different parts. Sorry, I shouldn't have filled it in like that because it'll think I'm trying to delete it. And so I can even say that that's going to be 1/2 plus 1/3 equals 5/6. So I can just use handwriting and say, I want to insert this image and put that into my document. So I can do just some handwriting and save that. So again, so many times I have students that will lose pieces of paper, and here in this digital, it's saved automatically in the cloud by Google Docs. So now I have this digital piece that's in there, and they can represent their thoughts with the computer. So many times I've had students who don't like to work. Once I give them a device, then they get that new lease on math, and they'll give me an opportunity. So it's nice to be able to provide that opportunity for students to give another method. Also here, I'm going to show you on my phone. So when I hop over here, and if I use my mobile device and click on this is my Pixel phone, it's an Android device. If I click on that, now I can utilize the different tools here. So if I use my camera, this helps me. I had so many students who like to write things down on a piece of paper. So I get access to my camera. I have math. I literally just take a picture, and now I can submit that image if I want and put that into my Google Docs. So I can take something I wrote down on a piece of paper or a whiteboard, or maybe there's some collaboration I'm doing and I run out of time and I need to leave at like students working using vertical non-permanent surfaces, or Eddie Campos's amazing like 360 math. So I can then just take a digital snapshot of these and then curate and save those things digitally. The other bit I can do is I can also save this as math. And so I can go ahead and say like, okay, let's take that picture. And now that it's typeset, the sweet part is I had that written down on a piece of paper, and then now it is typed in my Google document, and I can click on here and edit that because I don't want this equation at the end. And so now not only was it handwritten at first, now it's editable, it's in my Google document, and on top of that, it's also accessible. I can have it be read to me.
Dart. Line 1, 1/2 plus 1/3 equals. Line 2, 3/6 plus 2/6.
So that's a really cool way for students to be able to just write something down. They might not know what it is and be able to work on that. Again, I've had that too, where I was at a Starbucks here and some girl get tutored and she didn't know what 3 squared was. She didn't know what that squared component. She was writing 32 and the tutor's like, no, 3 squared. And so the girl then wrote 3 with a little tiny 2, and that 2 kept shifting around. She just didn't know it went into superscript. So with the speech input, she could just say 3 squared. And it could go up into the superscript, and she could see what that notation is. She could insert that, and then from there, she can have it be read back to her to help cement what does that look like? What is that math read as? So all of these notational
3 squared line.
So any of these notational components makes it easy for them to understand what that component is. So that's a really great way for them to be able to take something that's physical and then make it digital, and then have the benefit of technology where it's editable, it's accessible, and they can provide that opportunity. So all of those different input methods, it makes it really easy to use. So I talked about EquatIO Mobile, but EquatIO in slides, it's another great thing here. So I can have my students, I like to do a classroom document when I've done a demo with a classroom full of students. It makes it easy for them to, I give them a prompt and I say, everybody make a copy of that slide. You get your own slide, put your name on it. It's yours to be creative with. And that's really like taking that think, pair, share and amplifying it to the whole classroom because everyone can see everyone else's work. Now there is like a classroom culture that you need to provide and create there to make it a safe space to make mistakes. And so there's some other building things you need to do from a teacher standpoint. But it's a really powerful assignment after they see that there is more than one way to solve the problem than the way that I use and the way that I explain. And so here they could take that and they could do this on a piece of paper. Here on this one, I gave it as on the graph that I gave them ax squared plus b, and they can then go ahead and play around with these different toggles and sliders to see what do they have to do to make that. And they might see like, oh, b if b is 4. And they might be able to change these other ways and say, oh, there's like an infinite number of them because that a doesn't do anything as long as it goes through that point 0, 4. So it's a really great way for students to be able to explore a concept by using that Desmos integration that is just so awesome and amazing with that visualization. And if you search on Desmos, one of my favorite activities is Desman, where students start creating things. And then they might say like, oh, I want to draw a picture. So they'll start learning about domain restrictions to be able to make sure that this thing only goes from a certain way. And it's really cool. We have prediction in here for domain restrictions. So you can say like, what if I want to do all of those so if I want to make that from x as x goes from 1 to 3, I can go ahead and do that process. And so they learn what those endpoints are. Maybe I want to go from -3 to 3. So they can utilize that domain restriction without necessarily knowing about it. So that's a really cool way to learn about other bits and also to bring in that graphical component, which is a nice way for students. So many times when I talk to teachers as well, though, when they want to incorporate UDL, they don't know where to start. And I always say like the lowest common denominator is take something that you've already made and then utilize it. And so a PDF is a great bit here. So if you use the Texthelp's Read and Write PDF viewer, we can just go ahead and click on the EquatIO. You can use all those same tools in the PDF. The screenshot reader is really cool. This is just a functions summary page from a textbook. And so some of those things like that accessibility bit, what I could do is I can literally just screenshot this really difficult bit, and we should be able to figure out what it says and then read it aloud and also make it editable.
Find the difference open paren f minus g closed paren of x equals x plus 2 minus.
So you can hear that be read aloud, but on top of that, you can just say, hey, edit this with EquatIO, and then now I can start editing it. So it takes something that was physical. You can see it's just really just a picture here. This was scanned on a scanner that was not making it accessible, and now I've made it accessible. And so I can insert that math back in there into my Google Doc, into that PDF as a notational bit. So I can just drop that in there if I want. So it's a really great thing. Like, awesome, you have a great resource, just make it a PDF and then let your students use EquatIO so they can bring in all those bits. So I think is minimal work on the teacher part to kind of start working on that. I also think that Google Forms is a great way to do that. Like for warm-up problems and let it auto-grade, you can use EquatIO to put the answers in the correct answer. But here I can just tell my students like, oh, I can click on this and then I can do it however I want. Like maybe I'll just do my handwriting and say that I'm going to do 3x equals 24. So then x equals 8. That's what they would do on a piece of paper. Let's make that equals. And that's a 4. Here we go. And so I insert that math. That's what I want to submit here. And you can even do multiple choice options and add on the Google Form quizzes option. So when I hit submit, it's going to try to auto grade that so I can view the score. And it told me that this one's correct because I said that was an option, and this one's not correct. And I can give feedback. And so I can say, don't forget to fully simplify. And here's a link to a Google Doc lesson maybe on simplifying. So on that, like, there's no teacher impact. I set that up, I put those in there, and I kind of let it go, and I let that technology amplify my learning. And so I think that's a really great way to have that UDL approach be tightly interwoven with technology. Because here, if I do that at the beginning of my class, as a warm-up problem, I can then utilize that formative assessment to literally inform my instruction. I can go ahead as the teacher here, look at those responses, see what the students have given me. Okay, almost all of them think x is equals 8. You can see here too, you can use EquatIO Mobile to do a handwriting bit. You can take a picture from a piece of paper. So you can just see a variety of different works. And it won't auto-grade the picture yet, but I can just see all the different processes and what's correct and what's not, and know what is correct, and so I can move on it. And then also on top of that, I can go through and see the individual for those that it marked incorrectly and loop back around during that class and see if I can help address their misconceptions. Again, really cool because I don't have to wait until the next time I see them after I've graded it and they've been kind of missing that foundation to build upon for that next lesson. So it's really just-in-time formative assessment. I can utilize it to inform what I'm going to do in the classroom. So I'm really excited about all the UDL capabilities here in STEAM. I've emphasized the M part of STEAM, but I think really you can bring in a bunch of other bits in here. You can even have like a student respond with the EquatIO math space, and that incorporates a ton of different things. The EquatIO math space component, my daughter who's 5 thinks I make a drawing app because she likes to use EquatIO math space to just create a different bunch of different items. In our shapes here, we have a variety of manipulatives. She likes to do pictures with cars. We have a lot of mechanics items, and you can build problems with springs and pulleys and gears. And there's fraction bars, fraction circles. If you look next week, there's going to be so many super amazing elementary manipulatives like pattern blocks, base 10 blocks, pentominoes, tangrams. We're going to have smart shapes in here that'll be able to shade some fractions for us, more nets, 3D shapes. So there's going to be a lot of things. Check out next week. You'll be able to see all the new math space items that we have, and also you'll be able to import a picture. So those are some great bits that we have coming for next week to enhance this. So here I can also use the this freehand drawing, so I can do any bit that I want. So I can say like 3 + 2 = 5, and I can just submit that back into my response. So it's this digital whiteboard that I can use to create a response for a formative assessment or summative assessment, or just to also give those students those tools. Maybe they can just write 3 + 2 = 5, or they could use speech input. My daughter's 5 and she can't use LaTeX or other capabilities, but she wants to communicate what she can. And she uses EquatIO Math Space a lot of times to do that. So hopefully this UDL approach to STEAM helps make you think, and I would love to kind of jump back in and continue this thought process. We'll share this out as to some of the updates, but we did a STEM thing last year during the Kentucky Derby time, so almost a year ago with Simple K-12. And since then, we've done the EquatIO Mobile, the screenshot reader. We did multiple line prediction, the Google Forms quiz support. You can now edit native Google equations and MathML in Google Docs. And then we have a lot of stuff coming in more soon. So go install EquatIO. It's free for teachers. Students do require a premium license to respond to Google Forms and other things. But really communicate with us about it and leave feedback. That's how we impact it. And we want to make it each student have the ability to communicate in the method they prefer, so they can be engaged and really implement it and amplify that learning process to empower them to really communicate their thought process. Thanks again, and please let me know. Hit me up on Twitter or any other method. Anytime you submit feedback on EquatIO, I respond there, and really would love to foster and further this communication and how we can transform the STEAM component and STEAM experience for students to really empower them to communicate.